right, this is our first video with chapter 8 and 9. So let's go ahead and get started on our solutions notes. Now, for our mixture review, you're going to see some material you're already familiar with in regards to mixtures and some new material. Now, there are two types of mixtures. The first type we're going to talk about are heterogeneous mixtures. Now, one type of heterogeneous mixture that we need to discuss are suspensions. And these are mixtures that are temporarily mixed, but they eventually settle out. They have the largest particles of any other mixture or solution. And an example would be orange juice with pulp. I should have put with pulp on there. Because the orange juice with the little bitty pieces of orange, if you leave that sitting in a glass, eventually those little pieces of pulp or little pieces of orange float and settle at the bottom. So that's an example of a suspension. Now we're going to look at a second type of a heterogeneous mixture, and that's a colloid. And the particles in colloids come in clusters, but not single molecules like solutions. However, they never settle out like a suspension would. Now, an example of a colloid is mayonnaise. So something that is thick and never settles out would be a colloid. Now, the second type of mixture is a homogeneous mixture. And we call these solutions. So whenever you hear of solutions, we're talking about a homogeneous mixture when we talk about solutions. And solutions, remember, homogeneous mixtures are those that you cannot see the different parts of. So like water, rubbing alcohol, gasoline, all of those are homogeneous mixtures. Now, miscible is a vocabulary term, and it means substances that can be mixed. So miscible, they can be mixed. Immiscible means two substances cannot be mixed together. So miscible would be gasoline. You know, there's a ton of different liquids that mix together to make gasoline. So all of those substances would be miscible. Immiscible would be, an example would be like oil and water. Now, can gases be mixed with liquids? And the answer to that is yes. Think about when you open up a soda can and you pop the top and you hear the fizz, the sound. That's the gas being released, and they've actually pressurized gas to be down in the can to help keep it carbonated. And so that's an example of gases being mixed with liquids. And always know this. This is what's going to help you know what can be mixed together. Oily things are always going to mix with oily things, and watery things are always going to mix with watery things. So if it feels oily, it will mix with something else that feels oily. If it feels watery, then it can mix with something else that feels watery. And you can try this at home if you want to see if this really works. Hopefully we'll get to try some in class also. Now, some definitions. Make sure you know these definitions. A solution is a mixture that has the same composition, color, density, and it even tastes the same throughout. Okay, so you can't see any different part. It's one solution altogether. To describe a solution, you may say that one substance is dissolved into another. And the substance being dissolved is actually the solute. The substance doing the dissolving is the solvent. So let's look at some practice on that. A solution is a homogeneous mixture. We've already talked about that. The solute is the substance being dissolved. So it's going to be the purple test tube because that's the smaller amount. Solvent does the dissolving. So it actually helps do all of the dissolving so that that solute is completely dissolved. Now, a good way to remember how to determine the solute or the solvent, if you'll look, the word solute has 6 letters. The word solvent has 7 letters. So solute is the smaller word. It will always be the smaller amount. Solvent is the larger word, so it will always be the larger amount. So think about this. If you're making Kool-Aid, you have a little bit of powder that goes in a gallon of water. The solute is the Kool-Aid because it's the smaller amount. The solvent is the water because it's the larger amount. Okay, so here's another example. We have water on the left-hand side. We have potassium manganate on the right-hand side. And as you can see, we have a smaller amount of potassium manganate, and the larger amount is water. So that tells you which one is the solvent and which one is the solute. Now, let's talk about non-liquid solutions. Solutions can be gaseous or even solids. Some gas solutions. All mixtures of gases actually are solutions. So if two gases are mixed together, they're going to automatically be a solution in a homogeneous mixture. Air is a solution because it contains nitrogen, oxygen, and then small amounts of other gases. And so they're all mixed together to create the air that we breathe. Now, some solid solutions. Sterling silver contains 92.5% silver and a small percentage of copper. So that's actually a solid solution. We also call solid solutions alloys. And they are made by melting the metal solute and the solvent together, letting them cool, and then they become things like sterling silver that we use for our silverware. All right, now let's talk about actually dissolving something. This occurs at the surface of the solute. So at the very surface of the solute, the solvent is pulling particles away from the solute, so eventually it will get completely dissolved. The solvent particles surround the solute particles to do that, and there's actually a attraction of opposite charges. That's how the solvent particles pull away at the solute particles. And so like we've said, the solute particles are pulled into solution. So if something is called soluble, that means it can be dissolved. If something is insoluble, that means it cannot be dissolved. Now, how substances dissolve? Like the particles of any substance, water molecules are constantly moving. And so as water molecules, since they're polar, and what we mean by polar is it means they have two opposite poles. They have a positive area and a negative area. So what it means is hydrogen, like H2O, making up water, the hydrogen and oxygen do not share their electrons equally, so that makes the oxygen a little bit more negative and the hydrogen a little bit more positive. So molecules of sugar are also polar. And always remember, like dissolves like. So something that is polar can dissolve another substance that is polar. Something that is nonpolar dissolves nonpolar substances. So since water is polar, most watery things are going to be polar because the things that feel watery can dissolve things that feel watery, and oily can dissolve oily. So the oily things are the nonpolar molecules. And so this is the partial charge I was telling you about, just that the hydrogens are going to have a partial positive, oxygen having a partial negative. So I'm just going to show you some pictures. You don't have to write these down. I'm just trying to help you see what happens. So here you have a cluster of sugar molecules in the bottom left-hand corner, and the negative ends are attracted to the positive ends. The negative ends of the water molecules are attracted to the positive ends of the sugar molecules. And so the water molecules pull the sugar molecules into solution, so they slowly break them apart. And then the water molecules and sugar molecules spread out to form a homogeneous mixture so that you can no longer see the sugar anymore. Now we have an example of salt dissolving in water. So as you can see down here, the big salt molecule, and these are the little water molecules up here, and they're coming because they're attracted with that opposite charge, and they're going to start slowly pulling the salt away from the big molecule that it is. Now, water is a polar molecule. We've already talked about that. So a polar molecule is a molecule that has a positive and a negative side, and a non-polar molecule is a molecule that doesn't have a positive and a negative side. It actually shares everything equally, so it has no charges or partial positive or negative. And so again, like dissolves like. So watery things are going to dissolve watery things. Oily things will dissolve oily things. Now, this is going to be our last little thing that we do before the end of this video. Solids dissolve faster if you stir more, if you have a smaller particle size, and if you have a higher temperature. So just think about this way. If I have a big cube of sugar it's going to dissolve slower than if I break up the cube of sugar into granules. And so that's small particle size. So if the surface area is decreased and we crush it up, if we increase the surface area by crushing it up, it helps dissolve faster. Another thing to think about with high temperature, the way we make sweet tea, we boil the water and let the tea sit so that we have hot water to dissolve all of that sugar. And it dissolves quicker if we have it at a high temperature. Also, stirring helps increase the rate of dissolving because it's allowing you to come in, the molecules to come into more contact with one another. So there are several things you can do to speed up the rate of dissolving: stirring, reducing the crystal size, or the increasing temperature, and these are the three most effective techniques. And remember, reducing crystal size means you're increasing the surface area. Now stirring, this is, like I said, this speeds up dissolving because it brings more fresh solvent in contact with more solute. And the fresh solvent then attracts the particles of solute, causing the solid solute to dissolve faster. Crystal size. If you grind large crystals into smaller ones, it speeds up the dissolving process. And it allows more area to come in contact with the solvent that you're using. You're also increasing the amount of surface area by creating smaller particles, and so that increases the rate of dissolving. Again, we've talked about this, but increasing the temperature of a solvent speeds up the movement of its particles. And so as you speed up the movement of the particles, they're allowed to bump into the solvent more. And so it increases the rate of dissolving. Now when you're increasing temperature, since they're moving much faster, the solute particles actually can break loose a little bit easier than they would if you were at room temperature. Now, each of these techniques you can actually control. So these techniques can help you dissolve something faster, but if you need something to dissolve slower, you can also do the reverse. Lower the temperature, decrease surface area, things of that nature. And knowing how much each technique affects the rate will also allow you to control that more precisely. Okay, so we finished this video, so what I need you to do is go ahead and summarize, and I would like you to write a short paragraph to an absent student, someone that maybe didn't see this video, and ask them to, tell them what was the most important part about this video that you learned. I hope you have a great evening, and I'll see you in class.